Hi friends, now I am going to explain eigenvalues concept. So first definition for eigenvalues is let A is equal to Aij n by n be a square matrix of order n over the field F. An element lambda in F is called an eigenvalue of A if determinant of A minus lambda I is equal to 0, where this I is the unit matrix of order n. It means if we if the order of A matrix is 2, then we have to take the unit matrix of order 2. If the order of A matrix is 3, then we have to take the unit matrix also having order 3. Again, I am repeating the eigenvalues definition. Let A is equal to Aij n by n be a square matrix of order n over the field F. An element lambda in F is called an eigenvalue of A if A minus lambda I is equal to 0, where I is the unit matrix of order n. So friends, definition over. Now for clear understanding, I am going to explain eigenvalues with one example. So first of all, how to find the eigenvalues of any matrix means first of all we have to see the matrix of order. It means rows and columns are equal. It means we have to take the square matrix and find determinant of A minus lambda I by taking the unit matrix of same order. So example 1, find the eigenvalues of the order matrix A is equal to 2, 2, 1, 1, 3, 1, 1, 2, 2. Now solution, given matrix A is equal to 2, 2, 1, 1, 3, 1, 1, 2, 2. This matrix is 3 by 3 matrix. So we have to take that unit matrix of order 3 by 3. First, the characteristic matrix of A is A minus lambda I. That is equal to, we have to write A matrix here 2, 2, 1, 1, 3, 1, 1, 2, 2 minus lambda into unit matrix of order 3 1, 0, 0, 0, 1, 0, 0, 0, 1 is equal to 2 minus lambda into 2, 1. Next 1 minus lambda into 0, 1. Next 3 minus lambda into 1, 3 minus lambda. Next 1 minus lambda into 0, 1. Next 1 minus 0, 1. 2 minus lambda into 0, 2. 2 minus lambda into 1, 2 minus lambda. So we get the characteristic matrix of A is 2 minus lambda, 2, 1. 1, 3 minus lambda, 1. 1, 2, 2 minus lambda. Next, we have to find the characteristic polynomial of A. That is determinant of A minus lambda I is equal to 2 minus lambda, 2, 1. 1, 3 minus lambda, 1. 1, 2, 2 minus lambda. This is the matrix we get from here with determinant. And we already know that how to find the determinant of this matrix is equal to 2 minus lambda into 3 minus lambda into 2 minus lambda minus of 2 minus 2 into 1 into 2 minus lambda minus 1. plus 1 into 2 minus of 3 minus lambda. Now we get is equal to 2 minus lambda into 3 2s are 6 minus 3 lambda minus 2 lambda minus into minus plus lambda square minus 2 minus of 2 minus 1 here, right, 2 minus 1 here minus lambda plus 1 into 2 minus into plus minus 3 minus into minus plus lambda, that is equal to 2 minus lambda into this can be written in order, then we get lambda square minus 3 minus 2 minus 5 lambda plus 6 minus 2 plus 4 minus multiply with 2, 2 ones are 2 minus 2 lambda plus 1 into 2 minus 3 minus 1 plus lambda. Now multiplying this equation with 2, then we get that is equal to 2 lambda square minus 10 lambda plus 8. Next again multiply with minus lambda this equation, we get minus lambda cube minus into minus plus 5 lambda square minus into plus minus lambda into 4 lambda, and multiplying this one with minus, we get minus 2 minus into minus plus 2 lambda, again plus into minus minus 1 plus lambda. So by simplifying this equation, we get minus lambda cube plus 5 lambda square plus 2 lambda square, 7 lambda square. Next here minus 10 lambda minus 4 lambda is equal to minus 14 lambda, and here 2 lambda plus lambda 3 lambda minus 14 lambda plus 3 lambda minus 11 lambda plus 8, the constants here 8 and minus 2 minus 1, it means 8 minus 3, that is equal to plus 5. So we get the characteristic polynomial of A is minus lambda cube plus 7 lambda square minus 11 lambda plus 5. And now we have to find the characteristic equation of A is, we know that the formula from eigenvalues, determinant of A minus lambda is equal to 0, that is A minus lambda I value is minus lambda cube plus 7 lambda square minus 11 lambda plus 5 is equal to 0. Multiplying this equation with minus, then we get lambda cube minus 7 lambda square plus 11 lambda minus 5 is equal to 0. Now we have to find the roots for this equation. So let f of lambda is equal to lambda cube minus 7 lambda square plus 11 lambda minus 5. We assume that 1 is the root of this equation, then it gets 1 cube minus 7 to 1 square plus 11 into 1 minus 5, that is equal to 1 minus 7 plus 11 minus 5, that is equal to 12 minus 12 is equal to 0. So 1 is a root of f of lambda, and then lambda minus 1 is a factor of this equation. So again by using synthetic division, y means here it is a cubic equation, so cubic equation will have 3 roots. So now we get 1 root here. Next we have to find remaining 2 roots. For finding the remaining 2 roots, we have to using this synthetic division method. So by using synthetic division method for this equation, we get 1 minus 7, 11 minus 5, 1 is also a root. So 1 minus 7, 11 minus 5. Here 1 is root of this equation. So get here 1, 1 into 1, 1 minus 7 plus 1 minus 6, 1 into minus 6 minus 6, 11 minus 6, 5, 1 into 0. Already we get lambda minus 1 is the root of cubic equation, and lambda square minus 6 lambda plus 5 is equal to 0. So we have to find the roots of this equation. We get lambda square minus 5 lambda minus lambda plus 5 is equal to 0. Here we take lambda as common, that is lambda into lambda minus 5 minus 1 into lambda minus 5 is equal to 0. Here lambda minus 5 common, lambda minus 5 into lambda minus 1 is equal to 0. Therefore, lambda minus 1 and lambda minus 5, lambda minus 1 are the roots. So, we get the lambda values are 1, 1, 5. Hence, the characteristic values or the eigenvalues of the given matrix A are 1, 1, 5. సో ఫ్రెండ్స్, వీడియో నచ్చినట్లయితే లైక్ చేయండి అండ్ మీ ఫ్రెండ్స్కి షేర్ చేయండి. ఫర్ మోర్ అప్డేట్స్ ప్లీజ్ సబ్స్క్రైబ్ మై ఛానల్. థ్యాంక్స్ ఫర్ వాచింగ్.